Once we've actually designed and built something like this, we can add control, because everyone is really interested in programming because it's such an important subject, of course. But with Assembler, we're not fixed on one programming platform. Assembler is about integration. It's about people taking what they currently have in school, and it could be a microbit, or it could be something like one of these, which is this is the Board of Education, okay? And we can integrate different platforms into the kit, yeah? There's not one unique part to Assembler. We use nuts and bolts, okay? We can integrate with a number of different platforms, a number of different systems. I run some hackathon projects in the UK, and hackathons, you take different kits and you integrate them together, okay? And this is where Assembler is really flexible for the more advanced user. We're not just stuck with this kit. We can actually integrate lots of other different kits into it, and it's also compatible with other leading market kits as well. Here's an example of another robot. So this was designed by my 5-year-old. Okay, you can see some of the standard lengths are different. We've got the curved strip here. We've got the thinner strip here. This is linked strip, but we've integrated the 5-volt servo motors, standard 5-volt servo motors. Okay, and we're controlling these servo motors with the Board of Education, which is a parallax programming platform. It's very understandable, very easy for a young person to program with. Okay. Some of the other components. So we have tri-strip here. Now I talked about some of the engineering processes, and one of them is actually bearings, using bearings and press fitting bearings into holes. Okay. So I'm just going to take this bearing out here so we can use it. So this is a metal bearing used in everything from aircraft engines to printers. Okay. Now, what we want to do is we want to press fit this into the hole and make a nice tight interference fit. And an interference fit is a fit that means that once it's in, it won't come out. It won't come out. So at the moment, I've just pushed it in a little bit, but we have a process to actually push that home. So we've got a nut and bolt here. Screw it on. And using the assembler tool, which is here, you can see when we start to tighten that in the hole, the bearing is being push fitted into that hole. Can you see that? And that's called an interference fit. That's press fitting a bearing in the hole. That's an engineering process. And that bearing is in the hole, and now that's ready for a drive shaft to be pushed in. And here's a drive shaft. Okay. We can push that drive shaft in the hole quite simply, and we've got a nice rotational smooth motion. Yeah? The drive shaft is D-shaped. Why do you think we have a D-shaped drive shaft? Well, all the holes in the gears and the pulley wheels are also D-shaped. Yeah. What happens is, once one goes into the other, when the gear turns, the shaft is going to turn. It transfers the drive from one gear to whatever is connected. Yeah. So for instance here, we've got our gear train. We've got drive shaft, and drive shaft. So when we turn our input, or our drive gear, that shaft is turning that gear, which is in turn turning this gear on this shaft, and that gear is turning this gear. The drive shaft is connecting those two gears together, so you get nice motion throughout your whole assembly. Okay? And that's very important, because if the shaft was round, then the gear would just spin on the shaft and it wouldn't transfer the drive. So that's what we use in the real world. The drive shafts are different shapes. Yes, yep, yep. If you have a look at some motors, for instance, the motors on here, I'm just going to pop that wheel off. Can you see that motor shaft is D-shaped? Yeah? So we're really highlighting how things in the real world of engineering are made and are used. All of these are lengths that can be cut. I've discussed this in a little bit, but I'll go into a little bit more detail. So we've got curved strip here. All of the curved strips have lap joints on the end. It means that you can join. Okay, so that's quite nice. It's a nice feature. This is spacer tube. It's flexible. Okay, but sometimes you need to space distances between components. Okay, so in this instance, I wanted to space that distance. And all I would do is measure using my cutters. I cut to length, and then I can push this onto whatever I'm using. It may be a drive shaft. Okay, go down there, and then I can space a distance between two parts. Yeah? We've also got lots of angle components. So these angle components here, used for different applications. You can see they're being used here and here. So again, it's a kit that tries to be flexible. Flexible kit that you can build many things from.